everyone, welcome to Vedantu J English and I am Diksha Kaushal, your chemistry master teacher. So everybody do let me know in the chat box if I am clearly visible and audible to all of you or not, so that we can start with today's session. And here this is your 5 days challenge, right? Continuously for 5 days we are going to complete top 5 chapters, right? So today we will be completing chemical bonding, most important topics, along with the sample previous year questions from your JEE Mains. Then we will be doing after that coordination chemistry tomorrow, then GOC from organic chemistry, and last 2 chapters are from physical chemistry, that is structure of atom and electrochemistry. So I have picked these chapters because these are really important and you can expect around 3 to 4 questions easily from these chapters individually, right? So let's start with today's session, everybody. It is going to be a session of 1 hour, right? Maybe 50 minutes to 60 minutes roughly, and we are going to do most important chapters, not only the hybridization and MOT, we are going to do dipole moment, bond angle, and from some parts which you usually ignore, but actually from there the questions are asked, right? So let's start the session without wasting any time. Everybody, green hearts in the chat box for chemistry, and from chemical bonding, that is a very scoring chapter, right? So let's start with this one. Now this particular diagram is from your NCERT, you can see this over there. And from this, in the latest year, the very simple question has been asked. Let's understand that. What do you mean by this particular diagram? This diagram states that when two atoms, there are two kind of forces that are acting on it. One is attractive forces, then there is repulsive forces. When two atoms are away from each other, right, then they are getting attracted to each other. They are coming closer, attraction, and then they form a bond. Right? Now bond formation is that maximum distance that they can have, like the minimum distance that they can have from each other. If you try to make more, like if you want to make them more closer, and if you want more, like less distance between them, right? If you want to take them more closer, then they will start rebelling, right? I give this example to students. This is just like your real life. When you are away from each other, you miss each other, then you are like attracting, and then there is a specific point where you should stop, and that point is called the point of bond formation. So here, when the distance is decreasing, energy is also decreasing. Energy decreases means stability is increasing. So till bond formation, energy lies the minimum, stability lies the maximum. But if you try to further decrease the distance, then they will start repulsions and you will see a rise in energy and you will see instability of the bond. That is a very interesting thing. And from here, the question that they have asked in JEE 2020, that is the potential energy curve for H2 molecules as a function of internuclear distance. Very simple, direct question from your NCERT. Tell me, what was the curve? No, it looked like this. When you decrease the distance, energy will decrease, stability will increase. Then this is a point of bond formation. Where you have a bond formation, this will define, this particular distance will define the radius, right? And after that, if you increase, the stability is going to decrease, the energy is going to increase. So answer will be B, that is 2 is the correct answer. Very good everyone, very good. I can see Abhinav, everyone, yes. So now let's see the next category of questions that they ask you. This you must know that overlapping are of 2 types, right? One is head-on collision. Not collision, head-on overlapping. You have a lobe here, you have a lobe here. They overlap with each other on head-on, right? Then is sideways overlapping. You have a p orbital here, you have a p orbital here. They are doing sideways overlapping, right? So when you talk about head-on overlapping, that is sigma bond, and when you talk about sideways overlapping, that is pi or delta bond. Sigma bond, 2 lobes will overlap. In pi bond, 4 lobes will overlap, like you have this lobe, they will overlap with each other, this one with this one, this one with this one, right? But in delta bond, that is not like in that much detail in your syllabus. Delta bond, just remember 8 lobes will overlap. How they will overlap? Like you have, for example, I'm just showing you like this. Wait a minute, I'm just showing you like this. For example, these are the 4 lobes, okay? For example, these are the 4 lobes. If I say these are the 4 lobes, similar this is d block, this is d orbital. Similar d orbital you have here. This one will overlap with this one, this one with this one, this one with this one, this one with this one, right? So 4 of this orbital, 4 of other orbital, 8 lobes will in total overlap with each other. That is called as delta bond, right? That is known as delta bond, right? So always remember the strength of sigma bond is greater than pi bond. Overlapping is more in sigma bond. Then in case of sigma overlapping, if you see 2s overlapping is less, then 2s 2p, then 2p 2p, then you have 1s overlapping. This is the strength of overlapping. And in case of pi overlapping, p pi overlapping is less, then p pi d pi, then maximum is d pi overlapping, that is maximum. That means this delta bond is greater than the pi bond, because in delta you have 8 lobes that are overlapping. In pi bond, that is you have only d pi, for example, you have p pi bonding. And in case of p and d as well, you have only 4 overlapping. So in this case you have 4, in this case you have 4, in this case you have 4, in this case you have 8 lobes that are overlapping with each other, right? Now next we have is hybridization, and from here short like 100% sure, like I don't know why these atoms are moving here and there. Okay, so one thing from here, a statement based question they can ask you, and from here a standard question definitely guaranteed they will ask you. I mean, it's been so many years, I have never seen a single exam which has chemical bonding and a question they don't ask from shapes and hybridization. It is, if you're skipping this particular topic, you're actually just directly saying that, ma'am, I don't want to have marks from this topic, because this topic is sure going to be there in your exam, right? Most important topic from this chapter is shapes, hybridization, very important topic. Like n number of previous year questions you can see from here. I have picked just 1 or 2 questions, not that many, but you will see all the questions will be from the examples that I'll teach you. This will take more time. Here I will invest around 15 to 20 minutes. So have patience and let's look into this, right? So first thing is hybridization. So what exactly happens? What is hybridization? Hybridization is the mixing of orbital. Like s orbital and p orbital will mix and they will make 2 new orbitals, that is sp. Then sp2, sp3, sp3d, sp3d2, sp3d3. All these hybridizations will take place. But you know what is the question that they ask you? They ask you which, tell us the hybridization of the following formula, right? A formula, a compound will be given to you. You have to tell the hybridization. Ma'am, how to tell that? From a compound, a formula is given. How do you tell the hybridization? So this is a very important formula to calculate the hybridization. Let's see how. It says that half into total number of valence electrons in the central metal atom. The number of electrons in the central metal atom, like nitrogen has 5 valence electrons. Oxygen has 6 valence electron. Group number 17 has 7 valence electron. Group number 18 has 8 valence electron. Group number 13 has 3. Group number 14 has 4. Group number 15 has 5. That's how you can remember, right? Then plus total number of monovalent atom, if any, minus charge on cation plus charge on anion. That's it. This is the formula that you should remember. Now, ma'am, any example based on that? Yes. We have an example, and this was the question that was asked in 2021. Okay, so let's talk about this question here. What was the question that was asked? The hybridization they are asking you of the atomic orbitals of nitrogen in these three cases, right? Now either you firstly draw the structure and get into that process, or directly apply the formula. What's the big deal in that? Let's see. First is NO2 negative. Central metal atom always is less in number, that is nitrogen. So it will be nitrogen has valence electrons 5. Is there any monovalent atom? No. Oxygen is divalent, it's not monovalent, right? So it will be plus 0, and always negative charge will be added because electrons it has gained. So negative charge will be added, and here it will be 3. Just calculate the number. I'll tell you how to do the hybridization. Just calculate the number, right? Now in case of NO2 positive, you have half. This is 5 plus 0 because centrimetal atom is nitrogen. So 5 valence electron, no monovalent, and cation will be subtracted. So it will be 4 by 2, that is 2, right? Then the third one is NH4 positive, right? From here, same thing, half. Everybody in the chat box, let me see who will answer this one. Let me see. Yes, PDF will be provided, everything will be provided, right? Okay. Tell me in the chat box what you will write here. Number of valence electron in the central metal atom. So central metal atom is nitrogen. Valence electron from group number 15 is 5, right? Then you add monovalent atoms here. Yes, hydrogen is a monovalent. See, hydrogen, or you have group number 1 or you have group number 17. They are going to be monovalent, right? So here it is going to be 4 monovalent, and here you have subtracted 1 here. Why? Because positive charge will be subtracted here. So it will be 4 plus 4, that is 8 by 2, 8 by 2, that is 4. Okay. So that is going to be the steric number. What we call it? We call it number of steric number, or we call it number of hybrid orbitals, right? Now remember this thing. If you have steric number, where should I write it? Okay, so here I will write it. If you have steric number 2, it is sp. It is 3, it is sp2. It is 4, it is sp3, right? Then if the steric number is 5, it is sp3d. If it is 6, it is sp3d2. That's it. This is all you have to remember. Mostly they will ask you for 2, 3 and 4 only if they ask you the steric number and to calculate the hybridization from there, right? So you can say this is 3, that means this is going to be 3 means sp2. Okay, so this is going to be sp2. Total number 2 plus 1 is 3. Write it sp, 1 plus 1 is 2. This is sp3. 3 plus 1 is 4. That's how you can remember. And answer will be sp2, sp, sp3, sp2, sp, sp3. So answer will be first is the correct answer here, and that's how you answer this particular question. Right, everybody? First is the correct answer. Absolutely right. Absolutely right. And more of these kind of questions they can ask you in the upcoming exam, right? Okay. Now let's talk about VSEPR theory, right? In case of VSEPR theory, we talk about that lone pair interactions, because lone pairs are unpaired, they are not paired in a covalent bond. That's why their repulsions are more as compared to lone pair bond pair, as compared to bond pair. This is what you have to remember, right? Then VSEPR of central metal atom is number of sigma. Now see one thing. Number of hybrid orbitals 2, 3, 4, 5, 6 can be calculated from this formula as well, right? And these also can be, you know, what is this value? This steric number is actually equals to number of sigma bonds plus lone pair as well. If your number of sigma bond plus lone pair is coming out to be 2, same thing. If your number of lone pair plus sigma is 2, then it is 3, then it is 4, then it is 5, then it is 6. Same thing. It is sp, it is sp2, sp3, sp3d, then it is sp3d2. Now always remember in case of SP, you will always have a linear shape. Geometry, not shape, you will always have a linear geometry like this. Okay, you will always have two bonds connected like this. Okay, connected like this. One bond, one atom, other atom, they are connected at an angle of 180 degree. Right, this is your linear geometry. In case of sp2, you have trigonal planar geometry. Now, what do you mean by trigonal planar geometry? So, in case of trigonal planar geometry, wait a minute, let me see if 1, 2, 3, yes, 1, 2, 3, 4 it has, 1, 2, 3, 4 it has, here is the atom with 3, this is the atom with 3, wait a minute, 1, this one is, wait a minute, 2 and this one is 3, okay. This is your trigonal planar. In a plane, you have a triangle, that is trigonal planar, right? Then you have tetrahedral. How do you define tetrahedral? That has an angle of 109 degrees, right? That has an angle of 109. This is how tetrahedral looks like. Okay, tetrahedral looks like this. You rotate any of it, you will get the same diagram here, same structure. That is tetrahedral. The angle, each of them has the angle of 109. Then you have sp3d. Now, any one of you can tell me what do you mean by sp3d? Acha, we have learned about trigonal planar, isn't it? We have learned about trigonal planar structure. This is also kind of trigonal planar. Firstly, you will draw trigonal planar like this, okay. Then after drawing trigonal planar, we are going to, this is a trigonal planar, but this is trigonal planar is sp2. It is sp3d. In sp3d, you are going to have trigonal planar bipyramidal. That means it's not going to be trigonal planar, it is going to be trigonal bipyramidal. So you have two more bonds that you connect here. Here you are forming one pyramid. What do you mean by pyramid? Pyramid is like this, 1, 2, 3, it's forming a pyramid that you have, right? And this is another pyramid that it is forming. So it is trigonal bipyramidal structure, right? So it is trigonal bipyramidal structure. Bipyramidal structure, right? Then guys, we have 6. In 6 you have octahedral structure. That means in the same case that you had square planar, if you remember a structure that is square planar, you will make a square, that is a square, and you will place two bonds at 90 degree angle, and that is octahedral. Why octahedral? Because it has 8 triangular faces, 1, 2, 3, 4, 5, 6, 7, 8. That is why it is called as octahedral. This is all you have to remember. No, it's not square bipyramidal. I know. It is actually same as square bipyramidal, because in the square planar you are adding one pyramid, other pyramid. But we don't call it square bipyramidal. We call it octahedral. It has a name, that is octahedral, right? So it is called as octahedral. If you remember this one, right, 30% of the work you have done. This one that you should remember, that steric number is actually equals to number of sigma plus lone pair. Pi bonds are not included in the steric number, only sigma plus lone pair. Then 2, 3, 4, 5, sp, sp2, sp3, sp3d, sp3d2, linear, trigonal, planar, tetrahedral, trigonal, bipyramidal, octahedral. This should be on your brain, right? Now we will start doing some questions. Actually, every example is a question, okay? So I'll teach you so many examples here where I'll tell you that how to calculate the steric number, how to calculate it in an easy way, okay? So it's not like I am teaching you the theory part, these are all the questions only, right? And you will see these questions only, repeatedly they ask you these questions, okay? So now you will follow the way I teach you to, do the question, because Different teachers have different methods of doing. Might be you have learned some other method of doing this question, but I will give you a different method, right? If that suits you, perfect. If you find that no ma'am, my method is easy ma'am, I have another method, you can do your own method, right? Okay, let's see this one. So how do I calculate, right? Now I know that beryllium, firstly I will see the valence electron in beryllium. Hydrogen, helium, lithium, beryllium, boron. Beryllium is 4, right? In 4 that means 2 is 1s2, 2s2. So valence electron in beryllium in group number 2. Simply you can say beryllium belongs to group number 2. For group number 2, the valence electrons are 2, right? So I'll write the valence electrons are 2. And if you see, it is BeCl2. That means with chlorine, it is definitely forming, I don't know it's linear or what, it is definitely forming 2 bond pairs. Here 1 electron is consumed, here 1 electron is consumed. And we know that in the bond formation, only the outermost valence electrons are involved in the bond formation. The inner core electrons are not involved in the bond formation. Some students have this basic, they are not clear. So understand that only valence electrons are involved in the bond formation. So you have 2 electrons here and those 2 electrons are involved in the bond formation. That means you have 0 lone pair here, right? No lone pair. Now I will always calculate the lone pair. No doubt these are all the examples where you will not find any lone pair, but in the exam, examiner will not tell you, hey, there is no lone pair here. You have to calculate that now. So that thing you should have, that I will have to calculate always lone pair, right? Okay. So lone pair is 0. So that means sigma plus bond pair, that too sigma plus lone pair. Sigma bond is 2, 2 sigma bond plus lone pair is 0. So that is going to be sp. 2 means sp. Now we know that 2 means sp, and that is why it has a linear geometry that has 180-degree angle here. And also guys, remember one thing, in this case you have 180-degree angle, here you have 120 angle, here there is 109 degrees 28 minutes angle. In this case the angle is different, I will tell you that. Here you have angle 90 degree also and 120 also, that I will tell you how. Okay. Understood? Now if you talk about BF3, boron belongs to group number 13. It has 3 valence electron, 3 bonds it is forming with fluorine, right? So it will have 0 lone pair. So sigma plus lone pair is going to be sigma bonds are 3 bonds it is forming. 3 plus 0, that is 3. That means it is sp2. That means it is going to be trigonal planar, right? So the geometry is going to be trigonal planar, right? The next one is CH4, NH4 positive. CH4 is easy for you. I will calculate for NH4 positive. In case of NH4 positive, right? Ma'am, it is a cation. Ma'am, it is an anion. Why to worry? Why are you worrying about these things? You know how to calculate from steric number this formula as well. Now you know that. You know how to calculate from this or formula as well. It is coming out to be 4, right? Same thing I will apply here. I'll calculate that sp3 hybridization is there. So that's why it is going to be a tetrahedral shape. That is, this kind of structure will be formed here, right? This kind of structure will be formed here, right? Then one more thing, ma'am, how do you calculate the number of lone pairs here? See here, if you calculate the number of lone pairs, we know that ammonia has this structure, right? Now this lone pair is actually given to the hydrogen, this having positive. That's how this ammoniated ion is formed, right? Then you have PCl5. In PCl5, phosphorus is belonging to group number 15. That means it has 5 valence electron, and 5 Cl5 means 5 bond it is forming with chlorine. So it is 5 minus 5, that is 0 lone pair. So sigma plus lone pair is going to be 5 plus 0, that is 5. So 5 means it is going to be sp3d, that is trigonal bipyramidal is going to be the structure in this case. Okay. How to calculate the number of lone pairs? That's what I am telling you. Firstly, see the valence electrons, right? I am seeing the valence electron. Then I am subtracting the bond pairs from there, right? Lone pairs are valence electron minus bond pair. Here you have 5 valence electrons for phosphorus and 5 bonds it is forming with 5 chlorine means 5 bond it is forming with chlorine, right? Because chlorine only forms single bond, right? So that means 5 out of 5 electrons, 5 are consumed in bond pair. That means there is no lone pair here, right? So that's how I am calculating the lone pairs. Here if you see sulfur belongs to group number 16. That means the valence electrons will be 6. So 6 valence electrons. And if you talk about SF6, here 6 bonds it is forming. That means 6 minus 6 is 0 lone pair. So we can say sigma plus lone pair. Sigma is 6 bond it is forming. Lone pair is 0. That means 6. And 6 corresponds to hybridization sp3d2. That means octahedral is formed here. Right, everybody? These were all the cases where lone pairs were becoming 0. Right? Okay. Now we are going to see some examples where lone pairs are not going to be 0. Now these are the questions that they ask you in exams. You have to calculate the lone pair as well. Right? So I'll firstly talk about SO2. Let's talk about SO2, right? Okay. Wait a minute. I'll just write SO2 or O3 is also the example here, right? Let's talk about SO2. If you talk about SO2, I know nothing about this, right? I know only one thing, that sulfur belongs to group number 16. So it has 6 valence electron. And I also know one thing, that oxygen always form multiple bonds. Oxygen has a quality. Oxygen be like, I want to form 2 bonds. I am happy only in 2 bonds, right? This is the quality of oxygen, right? So oxygen always, this is the major thing that is very important for you in this theory, that oxygen forms multiple bonds. It wants to form 2 bonds, right? So oxygen will form 2 bonds here, multiple bonds. And here if I see 1 electron here, 1 electron here, 1 electron here, 1 electron here, that means out of 6, 4 will be consumed. That means 2 electrons are there. 2 electrons are left. Now 2 electrons are forming 1 lone pair. So I'll say that means 1 lone pair you will have. Now I don't know anything about the structure. I only know that there is 1 lone pair also here. That's it. That means sigma plus lone pair. If I say sigma plus, how many sigma bonds you have? Sigma bond is this sigma, this sigma. You don't have 4 bonds. You only have 2 sigma bonds. So that is going to be 2 plus lone pair is 1. That is going to be 3. So it is going to be sp2. That means it is going to show you a trigonal planar structure, that is this kind of structure. Now always remember, one thing to remember guys, one thing to remember, where should I write it? I should write it here, right? Always remember guys, when you are calculating geometry, you are saying lone pair also and bond pair also. But when you are calculating shape, you only see the bond pair. In shape, you don't consider the lone pair, okay? When lone pair is 0, then when lone pair is only 0, in this lone pair is 0, lone pair is 0, lone pair is 0. When the lone pairs are 0, then we can directly say that geometry and shape are going to be same. But if lone pair is not 0, if I say, let's say this is my lone pair, I am drawing this lone pair by this green atom here, I am drawing the lone pair. Now these are my bond pair, this is my lone pair. When I see the geometry, I'll say this is double bond O, this is a lone pair, right? Now I say this is a trigonal planar geometry, okay? I say this is a trigonal planar geometry. Geometry, arrangement of electron pair is trigonal planar. But in case of shape, I only consider the bond pair. Now I have to ignore the lone pair, that is this I have to imagine like it is not there only. Now can you see this is a bent V shape, it's like a V shape. Why bent V? Because these lone pair are going to cause some repulsion, it is going to be a bent V shape. V shape now, so that's why we write bent V shape. Now let's talk about the next one, that is ammonia, that is NH3, right? You don't need to memorize this. What's the need of memorizing this? Tell me. We are calculating this. Why do you need to memorize this one? I have never memorized this. If you ask me my SO2 what is the structure, I will also have to think that okay, we have to do this, right? Now nobody is going to tell you that NH3 has one lone pair. How do you define that NH3 has one lone pair? You will firstly say nitrogen belongs to group number 15, so it has 5 valence electrons. Now 5 valence electron, and it is actually forming 3. You can easily calculate the steric number here as well, but it's totally your choice. You calculate it from the formula. You're not liking this method, calculate it from the formula. You have 5 valence electron, half 5 valence electron. This is going to be plus monovalent atom is 3. There is no charge. 5, 6, 7, 8. 8 by 2 is 4. Calculate it from the formula then. Why you are worrying about it? I have already told you this formula. This formula, so you already know. We have done this formula. If you don't like this way, you can just put in the values in the formula. That's it. Why are you worrying? Right? Okay. There is no need to worry on this one. Right? So calculate it from the formula. This is 4. Right? 4 means sp3. That means it is going to show you tetrahedral geometry. But we also have a lone pair here. This is our lone pair. This is the lone pair what we have. So we have to neglect the lone pair in the shape. So I'll neglect this lone pair. Now if you see, this is not planar. If you see, this is not a planar structure. It is bulge out here. So this is not a planar structure. This is a trigonal pyramidal. This is actually forming a pyramid here. So this is a pyramidal structure. So it has a trigonal pyramidal shape, but the geometry is tetrahedral only, right? That's how you calculate this. Simple. Next formula is H2O. Now again, if you want to calculate it from the formula directly, oxygen belongs to group number 16, so it has half 6 valence electron. There is 2 monovalent. There is no charge here. So it will be 4, that is sp3. This is also going to be sp3. Okay. But here can you see one thing, that here you have 2 valence electron, ma'am. Arey ma'am, 2 valence electron, ma'am, we have here. One is this one. The 2 lone pair you have here. Acha, how do you calculate the lone pair? Lone pair is a big thing, right? Now you will say, ma'am, who told you that here you have, ma'am, 1 lone pair? Okay, that's why I told you that method, because lone pair calculation is a deal. So that's why I told you that that should be the method. Okay. If you see here how I calculated the lone pair, how I calculate is 5 electrons out of 5 valence electron, out of this 3 are occupied. That means you are left with 2 electrons. That means you are left with 1 lone pair. That's how I calculated. This is 1 lone pair. Then sigma plus lone pair is, sigma is 3, lone pair is 1. So I calculated it to be 4. Okay. Here you can calculate the hybridization, but if you want to calculate the number of lone pair, that will be, you have number of valence electrons are 6. Out of this, 2 are occupied in bond formation with hydrogen. So you will have 4. 4 electron means 2 lone pair. So that's how you will decide that 2 lone pairs are there. So 2 lone pairs I have here. 2 lone pairs I have here. When you have 2 lone pair, this is the geometry. But when you see this shape here, that is nothing but it is a bent shape. So we'll just write here, bent is the correct answer here. Let's talk about the next question. Both have same geometry? Yes. NH3, water, and they have same geometry. Okay. Now let's talk about SF4. In sulfur, sulfur belongs to group number 16, that is 6 valence electron, out of which 4 are forming bond pair with fluorine. So you have 2 electrons, that means you have 1 lone pair. Arey, 1 lone pair. 1 lone pair you have. Sigma plus lone pair is what? Sigma plus lone pair. Sigma 4 sigma bonds. Lone pair is 1, that is 5. So that means it is sp3d. But in this case, in sp3d, this is the structure. Now see, 2-3 things can happen. Either you can attach the lone pair over here. Either you can attach the lone pair here, or you can attach the lone pair here, right? So the best way of attaching the lone pair is on the equatorial position, that is that trigonal planar plane that you can rotate here, right? That has 120, this has 120 degree angle, 120 degree angle, 120 degree angle. This and this has 90, 90, 90. So you're always going to have lone pair on the equatorial position because they have more angle, repulsions will be less here, stability will be more. So always lone pair is going to be on the equatorial position. This is one of the questions from the trigonal bipyramidal geometry, that always the lone pairs are going to be on the equatorial position, that are these positions, right? Now, when you ignore the lone pair, this is the shape that you have. Isn't it like a seesaw, right? This is a seesaw shape. That's why we tell that this is a seesaw shape, right? Very famous question these are. Okay, then we have ClF3. Now in ClF3 again, chlorine belongs to group number 17. So that has 7 valence electrons. 7 valence electron and 3 of them are occupied in the bond formation with fluorine. So you have 7 minus 3, that is 4 electrons, that is 2 lone pairs you will have. 2 lone pairs. Now in this geometry, you need to have 2 lone pairs, and you will always put 2 lone pairs on the equatorial positions. So I will have these 2 lone pairs over here. I will have these 2 lone pairs on the equatorial positions, right? And can you see, this is the geometry, but when I calculate the shape, shape is going to be T shape. Can I see? T shape. Right? So answer is going to be T shape is the correct answer here. Right? Okay. Ma'am, how do I tell that the sigma plus lone pair? Sometimes I forgot to tell you, sigma is 3, lone pair is 2, so it is 5. That's why I considered sp3d. Okay? Forgot to write it here. Right? Now some other examples, like you have BRF5. You have BRF5. Now in this case, what you have chalo, let's not talk about that. Let's firstly see how do you calculate it. Bromine belongs to group number 17, so it has 7 outermost electron. 5 are occupied, so 2 electrons you are left with, that means 1 lone pair. If you have 1 lone pair, that means, beta, 1 lone pair, what do you mean by that? Sigma plus lone pair. Sigma is 5, lone pair is 1, so it is going to be 6, it is going to be sp3d2. Now in this case, you should have 1 lone pair here. So 1 lone pair you can put it here, and now what you will have when you have to ignore the lone pair to calculate the shape, that is square because of these 4 bonds, and this is a pyramid. Square pyramidal shape will be there. So the shape is square pyramidal, right? Last one is you have XCF4. Xenon belongs to group number 18. So it is 8 outermost minus 4 electrons that is consumed in bond pairs. So you have 4 electrons, that is 2 lone pairs. 2 lone pairs means that you will have 2 lone pairs. Now ma'am, why you are not, now some students ask ma'am, why you are not putting the lone pairs like this ma'am? Why lone pairs are not next to each other? Because maximum repulsions will be there. I want to have less repulsions. So that's why lone pairs will be opposite to each other, right? Now for the shape, I have to ignore this lone pair. So I'll take out this lone pair, and what you will have is, you will have actually a square planar position here. Okay? Right everybody? Tell me. Right everybody? Arey, what has happened? Where the students have went? Wait a minute. What has happened, guys? Chalo. I could see the students just now here, but now I think there is some technical glitch. Okay? Yes. So here you have a square planar structure. Right? And that's how you will tell all the structures here, right? Now guys, let's see, right? Acha, one thing to remember here, one of the students asked about H2O and this. So let me just tell you about H2O. In case of H2O, right, see what will happen here exactly. So I'll talk about that in bond angle. Firstly, let's do this question. A sentimental atom in a molecule has two lone pairs and forms three single bonds. The shape of this molecule is what? Now it has two lone pairs and forms three single bonds. So sigma plus lone pair bacha, that is going to be 3 plus 2, that is 5. That is going to be sp3d. So that is going to be trigonal bipyramidal. Now in case of trigonal bipyramidal, whenever you have two lone pairs, you always have those lone pairs over here. Two lone pairs means it will be over here, right, like this. Now it will have a T shape if you ignore the lone pair. So answer will be T shape, that is C is the correct answer here. Very good, that is your JEE 2021 question, right. Then if you see this one, amongst the following the linear species that you have, now here you don't even need to actually, you know, calculate the lone pairs and all. You just need to calculate the steric number. The one which has 2 will be your answer, right? Okay. So if you talk about this one is going to be 7. This is going to be, wait a minute, this is going to be, this one is linear, so I can see N3 negative is actually linear. So you can just directly tell N3 negative is linear. But still, if you want to calculate, you can calculate it from the shapes as well. That this is nitrogen. Nitrogen is actually having half. This is nitrogen is having 5 plus 0 plus 0. That is going to be 2.5 something, right? And here Cl. This oxygen is central metal atom, that is 6 plus 2 monovalent. So this is going to be 6784. That is sp3, right? NO2 is not exactly going to have a hybridization because of the coordinate bond here that you have, right? Because of this odd electron species that it is, right? Then if you talk about O3 that we already discussed, this is actually going to be sp2, right? O3 is going to be sp2 here. What you can take one of the atom, oxygen atom as central metal, other two oxygen atom as the surrounding atoms. They are not monovalent, they don't have any charge, so it will be 3. 3 is nothing but sp2. In case of nitrogen, you have half. Nitrogen is nothing, it is having 5 valence electron. Monovalent atom, there is no monovalent atom here, but charge is -1, so we will add +1 here, so it is going to be 6/2. Monovalent atom is not there. You have nitrogen, you are adding 1 electron. 6/2 is 3, it should be sp2, but it is not sp2. Right. This is not actually, because this is definitely linear shape. This is actually a linear shape. Okay? So here it is not working actually, right? So this is a linear shape that we also know from, like, for full chemistry we know that this is a linear shape. Having double bond here, negative, negative and then positive. They will be neutralized. Because of this negative you have N3 negative here that has a linear shape. Okay. So answer will be 4th is the correct answer. Next is bond parameters. Now we have bond parameters. Let's talk about that, right? Okay. Yes. Now let's talk about, guys, please don't spam here, right? So let's talk about bond parameters. So first is bond order. Bond order we will calculate from MOT also, but you need to relate these things here. Let's see. Bond order is the number of average bonds, can also be fractional due to resonance. Bond angle is directly, so like oxygen has double bond, nitrogen has triple bond. So it has bond order 2, it has bond order 3. If bond order is in fraction, that will be because of the resonance, that it has partial double bond, then bond order will be in the fraction, right? And bond order is directly proportional to the bond strength. More the bond order, more will be the strength of the bond, and inversely proportional to the bond length. You can see this here. Oxygen and nitrogen, we know that this has 3 bond and its bond is shorter, right? So more the bond order, less is the bond length, right? And bond order is actually defined by 1 plus number of pi bonds divided by number of sigma bonds, right? Okay, let's see bond length here. Bond length defined by the size of the atom. More is the size of the atom, increase in bond length will be there. Like you have down the group fluorine, chlorine, bromine, iodine, the size is actually increasing down the group. That is why their bond length is also increasing. If you talk about the number, whether they are sp, hybridized sp to sp3, so we see that single bond has maximum bond length, then double bond, then triple bond, right? And also bond enthalpy is directly proportional to the number of bonds that you have. More the number of bonds, more energy is required to break the bonds, and it is inversely proportional to the size of atoms, right? If the size of atom is very large, the bond length will be very large and it is easy to break those atoms. That is why bond enthalpy and size of atom is inversely proportional. But the exceptions are due to small size that leads to more electron repulsion. But in some exceptions that we will see here in your periodic classification, you must have seen this, that actually what happens, because some of them have very small size, and because of that very small size, their bond enthalpy should be very large. For example, fluorine has very small size, so its bond enthalpy should be very large, because the bond size is small, so bond enthalpy should be large. But actually fluorine does not have the maximum, it has the smallest size, but it does not have the largest bond enthalpy because of the repulsions in the lone pairs that you have in fluorine. Because of these repulsion, it will not have the maximum bond enthalpy, right? Now let's talk about bond angle, which is very important. Let's see how to calculate bond angle, right? And you will see a lot of questions that are based on bond angle. Let's see how to do that. One by one we'll do that, right? Firstly, if the hybridization is different, we know that linear has 180, then 120, then 109, then you have, it depends upon whether which bond you're talking about. Between two axial bond you have 180, between equatorial bonds the angle is 120, between axial and equatorial you have 90 degree. Octahedral has 90, then bent has 120, bent has 109 also. Wait a minute, yes. Trigonal bipyramidal has this. I have already talked about all these things. The angles I have already talked about. That's why I showed you the shape. Now first is based on different hybridizations, you can have the bond angle. So bond angle is inversely, now based on different hybridizations, you can have the bond angle. Linear, then you have this, you can say, you can just simply write SP, SP2, SP3. Based on hybridization, this will be the order of bond angle, right? Mostly they will ask you SP, SP2, SP3 only. Then if the hybridization is same, ma'am, let's say they are asking about water and ammonia. Ma'am, let's say they are asking about CH4, water and ammonia all have sp3 hybridization. In that case, you will see the number of lone pair. Like CH4 has 0 lone pair, NH3 has 1 lone pair, water has 2 lone pair. So bond angle will be maximum in this one, right? Now why so? Can you tell me the reason behind that? Why bond angle is maximum there? Can you tell me the reason, everybody? See, what exactly will happen here? Let me just draw a structure which has 1 lone pair. Now in the tetrahedral, 1 lone pair, bond pair, lone pair, bond pair, lone pair, bond pair repulsion is there. That's why angle is going to decrease in this case. Wait a minute. Opposite I have written. Decrease now. So it will be this one. Wait a minute. My mistake. This will be CH4. Right? It is also inversely maximum, then NH3, then you will have this one. See, Because of lone pair bond pair repulsion, this angle is going to decrease and that will fall to 107 degrees. So in case of ammonia, you will have 107 degree, this is 109 degree. And in case of water where you have two lone pairs, you will have lone pair repulsion. These will also repel each other. Then they will further repel this one and this one. So it will come more closer. It will be 104 degree, right? So it is inversely proportional to the number of lone pairs. If both hybridization and number of lone pairs are also same, in that case, you will see bond angle is directly proportional to electronegativity of central metal atom. More is the electronegativity, more will be the bond angle, right? If bond hybridization is also same, lone pair is also same, central metal atom is also same, only the surrounding atoms are different, then what you will do? You will say bond angle is directly proportional to the size of surrounding atom and inversely to the electronegativity of the surrounding atom. Is that clear to everybody? Right, everyone? Is that clear? So, the compound that has highest HMH bond angle, that is going to be which one? The highest bond angle, right? So, if you see this here, guys, definitely if you see this one here, what is the hybridization? This one, so we know that is sp3. This is also sp3. This is also sp3. In case of sulfur 6, this is half. This is 6 plus 2 monovalent, that is going to be 8 by 2. That is also sp3, right? How many lone pairs you have? See, sulfur is 6 and here you have 2 are involved. That means 4 electrons. That means 2 lone pairs. So here you have 2 lone pair, right? Here you have 1 lone pair. Here you have 2 lone pair. Here you have 0 lone pair. If hybridization is same, see which one has least number of lone pair. That is this one. So answer will be CH3 is the correct answer here. Directly we know that CH3 has maximum bond angle of 109. Okay, right? Acha, if you have to tell me between this and this, if you have to tell me the order without even looking at the data, we have CH4. Then we will have H2S or H2O. Then we will have NH3. Now out of these two, how I will tell which one is greater? How I will tell which one is greater? Now out of these two, what we will see, central metal atom is different. So it depends upon the electronegativity of the central metal atom. More is the electronegativity, more will be the bond angle. So we know that electronegativity of water is more as compared to sulfur. So answer will be H2O, then you will have H2S. So that's how you can write even the order here. Here they have asked you a simple question, but usually students are not able to answer this as well. But they can also ask you the order, and right now they are focusing more on the order kind of question that is asked in 2024. That says the correct increasing order of bond angles among BF3, PF3 and ClF3. So you have to calculate the hybridizations here, guys. Hybridizations are clearly different here. If you see BF3, BF3 actually is trigonal planar. We have already done this. This has sp2 hybridization, right? Angle is 120. And if you talk about ClF3, if you remember, Cl was like this. This was like this. F, F, F. If you remember now, we have already done this. PF3 phosphorus has 5 outermost electrons and 3 are occupied. That means it will have 1 lone pair. 1 lone pair plus 3 bond pair, that means sp3. So this will be sp3. Okay, this will be sp3d. So we know that this has maximum, so BF3, then PF3. BF3 has maximum, then PF3, then ClF3. So answer will be this one. Directly, you don't even need to calculate all of that. Just from the hybridizations you can tell. And hybridization, I have already made you a pro in that, right? Just from the hybridizations you were able to answer that. Then the next topic is, guys, dipole moment. Everyone here is highly electronegative. Yes, definitely we should consider that, right? Okay, now we have dipole moment, right? Dipole moment is actually the direction from, always direction will be from less electronegative to more electronegative, or it will always be from an atom to the lone pair, right? And bond polarity, it will tell you the polarity of the bond between two atoms of the bond, and molecular polarity, it is a vector quantity. And this all you don't need to know. If mu is 0, then it is a non-polar molecule. There is no polarity here, right? Now let's see how do you define dipole moment. Always remember it is from positive to negative. So this is positive to negative, right? So it will make a resultant here that will be from this space, right? So it is going to have some dipole moment. If you see this one, this is positive to negative, they are going to cancel each other, mu is 0. In this case, you will have positive to negative, Achha, remember one thing, this is also positive to negative. Remember one thing, here the angle is less, here the angle is more. If the angle is more, the resultant is going to have less value. Always remember this. If the angle is more between two vectors, the resultant vector that you have here is going to have less value. Theta is inversely proportional to the angle. If the angle is more, the mu that you have for resultant, mu resultant is going to have, is inversely proportional to the angle that you have between them. Here angle is less, so theta is more. Here angle is more, so the dipole, the resultant dipole moment is less. Okay? Now, let's see how to answer this. Achha, for answering dipole moments, you should know the shape. If you know the shape, for shape you should know the hybridization. See, either they can directly ask you, or they can ask you the bond angle or dipole moment in which the shape concept is applied. You should know, you should be able to draw the shape of that molecule. Only then you will be able to answer bond angle or dipole moment questions, right? So here amongst these, the number of molecules with non-zero dipole moment. So if you see beryllium, this will have this kind of shape, right? So this is non-zero. This is going to be non-zero because this is B, then you have F here. This is, this you should know from hybridization only. I have already done all these structures. I have done BeCl2, I have done BF3, then water also, this will make a resultant here. This will make, this is the resultant, they will cancel each other, mu will be 0. Mu will be 0 here as well. If you see water or ammonia, CCl4 is also going to have mu 0. HCl is not going to have mu 0. If you talk about water, this is oxygen. These are two lone pairs. This is H. This is not going to have mu 0. This is nitrogen, right? H, H and H. Always it is going to be from positive to negative, lone pair, atom to lone pair. This is having a maximum very good dipole moment. This is positive to negative, This will add up and it will give you a good dipole moment. HCl also will not cancel, they are polar. So answer will be 3 molecules, they will be having dipole moment 0. That is these one, right? Okay. Now the last topic of today is MOT, molecular orbital theory. Let's talk about that. Yes, everybody, let's talk about molecular orbital theory. Again, a very understood now one thing. See, the topics that I have taught you, calculation of steric number from the formula and its application in calculating hybridization and its application in calculating shape. If you know how to calculate shape, you can calculate the value of bond angle or the dipole moment, right? Now these actually, this all that I have taught you, this falls under only one thing, that is shape and hybridization. If you know shape, only then you will be able to calculate bond angle or the dipole moment, right? Now this is a different topic, that is MOT, molecular orbital theory, right? Okay, right? No, if there is no connection with the lone pair, you just have to draw the shape here. I have drawn the shape, I have seen from positive to negative, atom to lone pair. Even if I don't have any lone pair, even then they are not cancelling anything. They should completely cancel each other. Here how come I have, beta, if you see from maths, you know, if you have angle of 120 degree, then the resultant will be equals to same. Resultant, if you have angle of 120 degree, this has value x, this has value x, then the resultant also will have x value. That's how this and this value is same. Okay? Okay? Understood? Yes. Now let's discuss MOT, the last and the most important topic here, molecular orbital theory. That is, the valence electrons are considered to be associated with all nuclei in the molecule, and the molecular atomic orbitals combine to give molecular orbitals here. So atomic orbitals, they will combine to give molecular orbitals, and we will have two kind of orbitals, anti-bonding molecular orbitals and bonding molecular orbitals. Let me see how much time we have already dedicated. We have dedicated how much time? We have given already 1 hour and 10 more minutes and we'll be done with this, right? Okay, two anti-bonding and bonding molecular orbitals. Bonding molecular orbitals are low in energy and anti-bonding are always high in energy, and stability is inversely proportional. So how bonding and anti-bonding is formed? Bonding is formed by addition of wave function and anti-bonding is formed by subtraction of the wave function. Now you have two kind of bonding and anti-bonding. In case of sigma bonding molecular orbital, sigma will be with 2s, sigma will be with 1s, with 2s, it can be with sigma 2pz, and pi will be with 2px and pi will be with 2py. 2pz has sigma, that is by convention we take it like that, and 2px and 2py will have pi, okay, and always they will have equal energies, whether in anti-bonding or in bonding, always they will have equal energy, right? So bonding, either you can have sigma 1s, sigma star 1s. For bonding molecular orbital, you will have sigma 2s, sigma 2px, pi 2px, pi 2py, they are equal, they should always be equal, and sigma 2pz, right? Here you can have anti-bonding can be pi star, always in anti-bonding, in these cases just apply star, that will be the anti-bonding case. Now let's understand what is the electronic configuration here. Just remember the electronic configuration and you are sorted. Now how to apply the electronic configuration? Remember that if you have less than 14, less than or equals to 14, equal or less than, you can say equal or less than 14, or you have more than 14 electrons, or you have more than 14 electrons, guys, simply we will add here. If you have less than or equal to 14, what you will have here, this is going to be 2, 1, 2, 1, 2, 1, 2, 1. If you have more than 14, it is going to be 1, 2, 2, 1, 1, 2, 2, 1. Ma'am, what do you mean by that? 2 always means you have pi 2px, pi 2py. 1 always means sigma 2pz, right? These are going to be bonding and these are going to be always anti-bonding, right? So what we do in molecular orbital theory, sigma 1s, sigma star 1s, these we will take it as kk star, kk star, kk star, and in kk star always 8 electrons are filled. Right, in kk star always 8 electrons are filled. This is what you should remember. Now I'll tell you how to do the questions. First let's see bond order calculation from MOT is half number of electrons in bonding orbitals minus number of electrons in anti-bonding orbitals, that defines the MOT, right? And the trick is always remember for 14 electron you have bond order 3. When you decrease or when you increase, when you increase the number of electron by 1 or you decrease the number of electron by 1, it is going to be decreased by 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5. Okay, always remember that. And also remember that for paramagnetic and for diamagnetic, okay, if you have even number of electrons, wait a minute, just give me a second. Odd number of electrons will be para, even number of electrons will be, even number of electrons will be di. Okay, even number of electrons. This is a simple direct method of calculating this. Paramagnetic are having unpaired electron, diamagnetic are having no unpaired electrons. But B2, that is having 10 electrons, and O2 having 16 electrons, even though they are even, but they are still paramagnetic. That is the exceptional case that we have. This is the exceptional case that we have. Okay. Now let's see how to do the questions of MOT in a simple way. I'll do this with the help of trick, and I'll also make a structure here. Okay, firstly I'll make a structure. Let's say they are asking the following correct order, bond order sequence. So firstly I'll do it with the help of a trick. O2 negative, O2 2 negative, O2 positive, right? Now I'm going to do it with the help of trick. Calculate the number of electrons. This is 16, this is 16 plus 1, 17, 16 plus 2, 18, 16 plus minus 1, that is 15, right? So they are asking the bond order. We know that 14 will have 3. So 15 will be 2.5, 16 will be 2, 17 will be 1.5, 18 will be 1. Okay, so order will be O2 is maximum, then you have after O2 O2 positive is maximum, then you have O2, right? Then you have O2 negative, then you have O2 2 negative. So answer will be D, C is the correct answer. This we have done within seconds with the help of a trick. Okay. Now, if you ask me, ma'am, please can you make the structure, hai na? Ma'am, can you please draw the structure here? Ma'am, can you please draw the molecular orbital theory diagram? How I will do that? MOT will be, let's say I am drawing for O2, right? O2 has 16 electrons. Always KK star will be initially subtracted. That is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s is already subtracted. You have 8 electrons. Now we know that it has more than 14 electrons. So answer will be 1, 2, 2, 1. That is 1, 2, 2, 1. So you have to fill 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And this question is asked so many times that the two unpaired electrons in case of O2 lies in the pi star anti-bonding orbital. This is pi star 2py and pi star 2pz, 2px. This you should remember. This is sigma 2pz, this is pi 2px, pi 2py, this is pi star 2px, pi star 2py, this is sigma star 2pz. Okay, that's how you should calculate this one, right? Then according to molecular orbital theory, which of the following will not be a viable molecule, which will not exist, right? If you see the one which has 0 bond order will not exist. Now you have to calculate the bond order, calculate the number of electrons. I will do this with the help of trick only. Number of electrons in helium are 4. 4 minus 2 is 2. 4 minus 1 is 3. 2 plus 1 is 3. 2 plus 2 is 4. Okay? Now if you see this here, right? Which of the following will not be a viable molecule? This can exist, that can also exist. Hydrogen, helium. Helium is 2. 2 into 2, 4. Okay? So here, let's draw the diagram only, guys. And with diagram only, na, this is, let's say, how many electrons we had? 2 here, na. So here it will be sigma 1s2. This will be sigma 1s2, sigma star 1s1. Sigma 1s2, sigma star 1s1. This is sigma 1s2, sigma star 1s2. So this is going to have 0. This is bonding minus anti-bonding by 2 is going to be 0. So answer will be this is not possible. So H2 2 negative is having 0, so that is not possible. The one which has 0.5, they are very unstable. These will be unstable molecules. These will be very unstable molecules. Okay. Then last one is magnetism. I have already told you. Diamagnetic is which has all the electrons paired. Paramagnetic is which has at least one unpaired electron, right? So we have talked about that how to calculate this directly from the trick, right? Amongst the following, the diamagnetic molecule, calculate the number of electrons. Arey, big deal, no ma'am, big deal, no ma'am. How many electrons here? 6, this is 6 plus 8, that is 14 electrons. It has boron 10 electrons. This has 7 plus 8, 7 to 14, 15 electrons. This has 16 electrons. Boron and oxygen come into the exceptions. That's why they both are paramagnetic, right? But we know that odd electron species is actually paramagnetic in nature, and even electron species is actually diamagnetic in nature. So we can say first is the correct answer directly from a trick. Directly from the trick that I have given you, that all the odd electron species are diamagnetic, even number are paramagnetic, but with all the even number species are diamagnetic, odd number are paramagnetic, but B2 and O2 will be paramagnetic even though they are even number of even species. Okay, which of the following molecules show paramagnetic behavior? Again, from a simple trick we will do this. Simple trick, guys, we'll do this, right? This is 16, this is 14, this is 9 to 18, this is 32, right? And this is chlorine 35, 35, na? Yes, right? Okay. So if you see this here, number of unpaired electron they are asking you. We know that they are asking you which of the following shows paramagnetic behavior. This is paramagnetic. Then you find any odd number of species, that is paramagnetic. So 2 species will be, A and D will be paramagnetic. Wait a minute. Why so? Why so? Paramagnetic, it shows paramagnetic behavior, na? Just give me a second. So which one is paramagnetic in nature? If you see this one, according to the trick though, the answer should be A and E. Unpaired electron is paramagnetic, O2 is paramagnetic, and S2 is paramagnetic. Wait a minute. Sulfur has how many electrons? Let me see that. 16 to 32, right? And the one with even, if we say, wait a minute, just give me a second. Even are diamagnetic, odd are paramagnetic. Cl2 has what? Wait a minute. Wait a minute. 34 electrons. This is what I have done wrong. 34 electrons. 34 electrons it has, right? So 34 electrons. Now we can see that why we have this and this as paramagnetic, 16 and multiple, right? Sulfur will show same property as oxygen, right? That's why this oxygen and this sulfur is paramagnetic in nature. Okay, This is 34, that's why it is, and these two are the exceptional cases like B2, O2, S2, they are paramagnetic even though they are even number of electrons, right? Because sulfur is going to show the same situation like oxygen, right? Okay. It is going to show because they belongs to the same group, that's why they are going to show the same situation, right? Same kind of bonds they will show. Right, everybody? So that's it for today. Now I'll see you all in the next class, and do remember that MVSAT scholarship program is right now at off, right? And MVSAT scholarship program, what you have here till 2nd of November, right? You have like you can apply to this one, and it has been extended for you. You can get 100% scholarship, and you can get iPhone, iPads and what not. Just by giving this test, this is your last chance. If you want to give it, then here's your last chance, right? And also guys, before going, do remember that we are going to launch our Sigma crash course, where we will teach in a fast manner. We will save your time along with the questions, with the smart tricks that I have just shown you, right? With those, we are going to simplify the questions, right, with less time and more knowledge. So that is going to all the headlines for that crash course will be there on 5th of November. That will be there, right? So wait for that and hit on the like button that we have for 5th of November Sigma crash course, right? Okay then guys, I'll see you all in the next class, that is for coordination chemistry. Till then, bye bye, take care, bye bye everyone, and do write it down in the comment section, right? Have you liked this session, right? Do you like these kind of sessions? In less time, we are doing so much, right? So do comment it down. I'm waiting for your comments. See you all tomorrow at 7 p.m. Bye bye.